So I will in this session we'll try to understand what is AWS ECS. Probably in previous session we have already come across what is ECR, that is Elastic Container Registry, and in this session we'll try to understand about Elastic Container Service, how it is differ from register as well as service. Okay, so this will be the agenda of the session, and we'll move on with the object, that is ECS, what exactly it is, and why should we use it, and how it is going to work. Some example scenarios, and we'll try to understand the benefits of it. Okay, so what is AWS ECS? So Amazon's provide that is fully managed service. In one, this include there. Okay, so it stands for Elastic Container Service. So it's a fully managed container orchestration service provided by the Amazon Web Service. So the orchestration is the words actually refers to something to do automation. So just to optimize many more work in one single path, that is we call it as pipeline, right? So altogether we use some tools to do auto or to do automation, all those things, right? For that we'll call it as orchestrations. Fine. So container orchestrations are the automation things service provided by the Amazon Web Service. Okay, so it allows you to deploy, manage, and scale Docker containers in controlled and secure environment. So we used to use Elastic Container Registry to store your packaged Docker application image. Okay, so for the storage purpose, we were using the ECR. So it's something that is nothing like Docker Hub. Okay, so we used to store there. Okay, so once we have stored, we need to pull it, and we need to deploy it in our server, right? So in Amazon, they have provided ECS, that is to deploy the containerized image. We have a platform that is being managed by the AWS, that is Elastic Container Service. Okay, so it will be allow you to deploy your application. Once after deploying, even you can able to manage or scaling up, scaling down, or if there is changes in any that is a new container got updated, then we can deploy the new one like that. Okay, skills container in the controlled and secure environment. Fine. And next is ECS abstracts the complexity of managing the infrastructure as well as orchestrations of container, making it easy for developer to focus on building the application. So in traditional way, we used to even keep monitoring of the usage, or how many users are trying to access the application, and what is the basic infrastructure to be provided to process the application or the request with minimal time of response. We need to handle all the infrastructure manually. So while deploying in ECS, that is the maintaining of infrastructure, networking, security thing, everything is being taken care by the AWS. Okay, and even do the automation things also. Even once after the ECR got updated with the new registry, automatically it will go and fetch it from there, and it will move on. So, but we need to configure everything initially. So once we configure, we can use it for as many time as we could. Okay, since it's a repeated task, right? That's the thing. Okay, so thus it will make developers to keep concentration on building the application rather than keeping the concentration on providing the service to the end users without any troubles and making their application available all the time. Okay. So we just understand what exactly is all ECS is, and we'll try to move on why we should use. So anymore, we have already know why we should go with ECS and all. We'll try to understand in depth also. Okay. So container management, like simplifies running and managing and scaling containerized applications. So as I just mentioned, right? So if you want to run your application, so we need to have the server with the proper infrastructure and the platform, right, to deploy our application. So thus the ECS is going to take care. What exactly we going to do, the manual thing is being taken care by the ECS. That's it. And when it comes to integration, seamless integrations with other AWS services. So obviously, since it is the service being provided by the AWS, definitely seamless integration is a added advantage since it is restricted to AWS ecosystem. Fine. So if you have your own organization application, so which should be accessible only for the employee of that organization, we can deploy it in the VPC. Or even though if it is in public, we can create IAM and we can restrict the things. And we cannot predict how the request inflows will happen, so we cannot keep monitoring all the time. So we do have the load balancer on who take care of diverting the traffic subject to request, and to monitor the logs and if fingerprints everything. So we go with the CloudWatch and CloudTrails things. Fine. And scalability, so automatically scales containers based on demand. So when there is a huge traffic spikes up, okay, so automatically by analyzing the that is incoming traffic, it will going to provision additional infrastructure. Okay. And flexibility supports two launch types. So here they have provided it two platform to deploy your application. One is Fagret, it's something like a Lambda, so it's a completely serverless, so where AWS managements the infrastructure. Another one is we can deploy it in our EC2. So you can create an EC2 and you can integrate with, or else you can go with the also. Okay. And the next is the most important part is security. So offer strong security using IAM roles. So we can restrict who can access what and who cannot access what. Okay. So task based permissions and encrypted data handling. So each and every transaction will be encrypted. Okay. And cost effectiveness, you only pay for the resources you consume. In Elastic Container Service, we will be paying for the infrastructure. What we going to use, like to run EC2, we use the infrastructure, right? The underlying infrastructure. For that, we will be charged for not creating any task like things, but you will be charged for the resources we will be using. And it's not included in free tier, but it's part of chargeable. So it will be based on the duration how much we will be running. Okay, so we just understand why should we go with ICS when complete your organization management is in the AWS ecosystem. So in that case, we can easily go with ECS. How does it work? So cluster creation. So initially, so assume that we have already packaged Docker container image. Okay. So post that we will be going with ECS. So initially we need to create the cluster. So cluster is nothing but or if you have one or more infrastructures or the system, altogether we call it as cluster. Okay, so you define an ECS cluster which is logical grouping of resources I just mentioned, right? So if you have three systems in your home, you can direct, yeah, that is serving some resources to the end users, you can directly call it as cluster without like doing system 1, system 2, system 3 all together are doing the same purpose and for the same task, so we can call it as cluster like. Okay, so resources can be EC2 as well as find it. And once after defining your infrastructure, okay, so you need to define the task. So what exactly is all, you specify the like configuration of your application in the task definition, like what image should be pulled and what is the memory and CPU requirement of your image or the container, everything will be mentioning here. And service deployment, so ECS service manages execution and maintain the desired number of running tasks. So how many tasks it is going to run, everything is being taken care by this. And load balancer as well as scaling. So we all know that why do we required. So ECS integrates with elastic load balancer as well as auto scaling tasks based on metrics like CPU or the memory usage. So either you can opt any one of these, or you can go with any of both the thing also. So we cannot always keep target on memory usage. So the memory will be the huge in some cases, but the CPU utilization might have been reached maximum. In vice versa, the CPU usage is quite normal, but the memory usage has extended. So we need to keep an eye on both the things. So it should be better to go with and options, so that it will be validated both in CloudWatch. Okay, that is we going to create data driven event based, right? That is, and obviously we'll be using the CloudWatch for monitoring any logs and as well as metrics. Next is example scenarios. We'll try to understand from the example. So thought, if you are deploying the microservices, a company wants a deploy microservices based architecture. Each microservices is containerized using the Docker. So you have your package that is jar. If you are going with Java application, you will be having the jar file. Okay, that is your packaged application. But you need to make it into Docker container image. So you will be writing the Docker file to push whatever the jar file has been there into the Docker container, and we will be having the Docker things. Okay, so AWS ECS enables them to deploy and manage multiple services independently. So you will be deploying each microservices independently and use Fire to avoid infrastructure management. So if you want to lessen your headache things and then go with the serverless, so that the things will be managed by ECS, or else if you are going with EC2, you need to configure it manually, or else there also we can go with some automation tools like Ansible or the Terraform. So scales individual microservices based on demand only if you are going with Fabric. If you are going with the EC2, either you should have to be written some scripts, or you required to have manual interventions. Okay, and batch processing. An organization runs periodic data processing job like log analysis and last time task analysis. They use launch a cluster of containers for batch jobs. So they're going to launch a single cluster, sorry, for container things. Okay, cluster of containers. So one cluster will be used for many containers like things. Use Magnet to scale down after job completion and reducing cost, so that it will going to take care by itself. So when there is huge traffic, it will going to scale up. If it is there is less traffic, it will going to scale down the things. Okay, thus we can optimize the cost. So when it comes to web application hosting, a startup deploys a containerized web application with ECS using the ECS on EC2. Okay, so they going to here they have used EC2. Okay, so in I will going to show in demo session. We'll try to deploy some web application too. Fine. So next, we can integrate with ECS with AWS code pipe code build, and that is the complete AWS DevOps setups where containers are built and deployed automatically after code change. So containers are built, that is, if any changes are found to be in the GitHub repository or the code commit, so automatically it will be pulled or it will be webhooked by the code build, and further it will be deployed using the ECS. Okay, new containers replace old ones seamlessly using the rolling up strategy. Fine. So here are some key benefits we do have. So fully managed service for container orchestrations and tight integration with AWS ecosystem, since it is a part of AWS. So flexibility to choose between EC2 as well as serverless things. Highly reliable as well as scalable and more secure. Since these components or these keys are being handled and is responsible by the AWS. That's the reason. So now we have already understood. So what is ECS and why should we go it, how it is going to work, and some key benefits, and we all do also come across some example also. So we'll obviously, without having the practical or the hands-on sessions, we won't be getting much thing. So just move on to the practical session. Okay, so we'll try to understand what exactly the things that is how it is going to happen. Okay, so initially we go and create the container registry. So why do we require container registry? To store your container based image. Okay, fine. Here I'll be going with the mutable since I won't be doing any other upgradations or the changes. Okay, so we'll just creating some repository here. Inside this repository I need to push my containerized application or the docker thing once after creation. Okay, so here we have html page, fine, all here. So here I have written the docker file. So my docker file contains that what environment or what platform should be used. Here I will be using the nginx as a base platform. Inside that I am copying the index.html to this path, that is inside the nginx operating systems or the platform. Okay, so I am exposing the port 80. So this file is going to be accessed, uh, public id followed by the port number. Okay, so once after the container application is created, I cannot go all the time inside the container and I need to run this application. For that purpose I will be using this cmd. Okay, so the cmd command, once the container got created, automatically the command will be running parallel. So here this is the command, to run the things. Okay, so for just information I will have told you. Okay, now once after creating the registry, oh sorry, repository, both are quite same. So we have created the private one, right? So we need to push this application into here so that I can able to access further. Okay, so I have already written what has to be done post, that is while creating the container. So this is completely, the docker file is completely related to container specification. Fine. So what my container should contain and how it should run, and my container should be available in the port 80. Okay, so whatever the command I am going to run in further is completely related to the docker files. Okay, so for that you need to create IAM row user first and provide the ECS, that is sorry, ECR permissions, so that you can able to do the things. Once after providing that, just pass the command like AWS config to get login to your Amazon CLI thing. Okay, so thereafter you can go and perform the things. So to push the command or to push your container, docker container, here we have a command. So we go here and we'll try to, okay. So now the docker build -it tag demo is my name of the container. Dot represents the current, that it will go and fetch the name, that is docker file in the current directory. Okay, so this command will help me to create an image like windows. We have an image, right? Windows ubuntu thing, like that it will help us to create the image. So once after that we need to tag. So why it is required to tag? So we should mention that this image should be pushed to my account. For that I will be using the my account name and all. Okay, so now it is tagged and we'll try to log into our docker, that is AWS register thing. Okay, so obviously I should go with this. Okay, Just provided the root access. So now the login is successful. Once after login is, that is, you have completed the authentication of Docker account, you just go and push the thing. So if you are going beyond 12 hours post login, so the token will be expired. So either you have to delete the existing token. Sometimes dynamically it will get updated in the, that is config.json file. Sometimes it will throw in error saying that denied. So re-authenticate, the token has expired. Kindly re-authenticate to push the process, like then it will show you some errors. Okay, so in that case, we just navigate to this location and try to delete this JSON file. Okay, or else you just take a root access and perform all the steps once again. Okay, so thus we have successfully pushed our that is container image, docker container image into container elastic registry, sorry, elastic container registry. Fine, now we can able to see here, this is your application. Fine, so anyhow you have your application on cloud and you required platform to deploy it, right? So we'll go and try to deploy the container. Fine. For that, I will be choose. I will be right now. As of now, I will be going with the Elastic Containers service. Thereon, we'll move with Kubernetes. Okay. So just click and open the thing. So fine. So initially, we need to create the infrastructure, right? That is, once we are done with creating the cluster, obviously we can go and create, define the task. Okay, so we'll be taking web app, and here I'll be going with serverless. I don't want to go and create each and everything manually. Okay, so if you are going with EC2, you need to create group permissions and all the things, so that we'll go with serverless things and hit create. So the creation of infrastructure and maintaining of infrastructure is completely being taken care by the cloud formation. Okay, so let the progress get complete, so that we can go further and define the task. That is, what image should be pulled and what is the specification of my container, everything. So now we have the platform to deploy our application, but still I haven't defined what to be deployed in my cluster. Okay, for that we'll go and create the task. Okay, so just provide the name of the task. It's completely up to you, but always try to choose with these things. Okay, so and all the infrastructure requirement should be matched with the cluster. Okay, so that you won't be find any much difficulty in accessing it or configuring it. Okay, so this is the container specification you are giving here. Okay, so 2 GB is more than enough to run any web pages, simple web page. Okay, so task role. So if you are trying to access any other services inside the AWS to run your application, on that case you required to provide task role. Okay, so here I am not accessing any RDS things to store data or retrieve data, or for authentication thing I am using any Dynamo DB things. Okay, so I don't want anything. So automatically the task execution role. So what are the required permission? Sorry, what permission is required to run your application? By default, it will going to create, that is execution role. Okay, so here we will be going with just provide the name of the container and go back to your registry and copy the URI. Okay, this is the address of your container. Okay, just paste it here. And if you have provided more security, you can just private register you can provide, and you can just pass the credential. Okay, and here it is port mapping. So you need to provide the port number in which your application is going to be accessed. So we have already saw that our application is available in the port 80. If you have updated the port with port number differently, you need to provide the same port number here. Okay, so just leave it as it is, and if you want, you can go with any things and the log monitoring. And here we have a health and restriction thing and timeout, network configuration, everything. Okay, just try to explore the thing. As of now, I just created the task definition and I have already cluster. So I need to deploy my task in my cluster. For that, we'll go here, hit the run task, and automatically by default I have only the one cluster is created. I will be choosing it. Okay, just keep the things as it is. Click on create. Okay, so now the status is pending. So now my task is completely deploying in that cluster. So we need to wait till the deployment is completed. Okay, see here it's provisioning. So infrastructure is provisioning subject to container requirement. Okay, now our uplink, that is our server is running. So just get into the server and just go with the network binding to access your application. So you have multiple ways to access your application. So this is your cluster, that is this is the primary infrastructure of the platform. Okay, so the thing should be running properly and it should be in the green status running. There won't be any issue. Just get into the task, and one thing you can access from here, public IP followed by the port number, or else you can just go for network binding and click on the link here. So they have already mapped the thing, so just click on the link. You should be able to see your application. See, so this is the application we have deployed. Okay, so for clarification things, okay, fine. See here. So see, the same website we can able to access from the infrastructure, that is ECS, Elastic Container Service. Okay, so once you are done with the demo or the hands-on practice, always be remember to delete all the resources whichever you have created. So initially stop the task which you have initiated. Okay, so once after the task is stopped, okay, just get back here and delete the cluster. So while deleting the cluster, you may encounter some errors because you might have not stopped the task. So the task which is associated with this cluster, since it will say that deprovisioning or deregistering of resources cannot be performed like that. Okay. So now my cluster is deleted. Okay. So here you do not have any cluster, but you have a task here. So just go inside this and select the task, action, deregister it. That's so we created initially cluster. The cluster was deleted, and we created the task. Even the task is deleted, and another one is we have created the repository to store the Docker container. Just go there and select it and delete. That's it. So by doing this, you can avoid additional billings from AWS. Okay. So this is all about the AWS ECS. This is how you can able to deploy your containers, that is a Docker container, using the ECS. And in further classes, we'll try to deploy same using the EKS, that is Kubernetes server service. Okay, how it is going to happen, we'll go and see all those things in future videos. Okay, so thank you for being a part of this session. So if you have any query regarding this, please do let us know and we'll try to cover it.